Bona tarda. Hi, everyone here in the room. I'm happy to see that so many people is still here waiting for this talk. Or maybe for the raffle, I don't know. But anyway, just let's start with the introduction. As have been presented, I'm Christian Adell. I'm working for Schibsted. Schibsted, probably you know some of the companies that we are owning here in Spain. We are part of us is InfoJobs, Vivo, Mil Anuncios, so several marketplaces. But also Schibsted has presence in the Norwegian countries. We have some media houses there. So it's a quite global company, distributed across several markets and several cultures. About myself, I have developed most of my career as some technical problems. Probably have to adjust this. So disconnect and reconnect. So about myself, I was a traditional network engineer, so spending most of my time working with the CLI, just going through pickup traces, doing this kind of stuff, until I decided that it was time for me to move to a more development approach. So I did the move, and I started working on this kind of stuff. So just before starting this presentation, because it's quite difficult for me in this kind of audience to understand which should be the approach that I have to take. And just a quick poll. How many of you have Wireshark in your Docker app, in your Doc app? So raise hands. Wireshark in the Doc application? Yeah, so quite a few. It's interesting to see that there is people interested in this kind of networking. But I was also expecting to be people in the audience that doesn't care too much about networking. Because, you know, networking probably is not the area in DevOps or in IT that has adopted networking DevOps culture so far. So what's this presentation going to be about? We could spend this half an hour talking about some cool new technologies like segment routing in IPv6 to do NFV chaining. This is cool stuff. And also, who can resist this kind of lovely RFC style? Nobody can resist this. But yeah, this is not going to be the approach. We could spend the time talking about the dramatic improvement on network operations over the last 20 years. So we have moved from Telnet to SSH, doing the same. But no, this is nothing to talk today about. We could talk about other cool topics, because DevOps is something that is starting to move things in networking. So there are cool words like SDN, network programmability, intent-based networking, open networking, Linux, SD-WAN, OpenConfig. So cool stuff that is going on the networking area. But this is not going to be our focus today. If you want to learn more about this, there is here in Barcelona a meetup that some people talk about this kind of stuff. It's a meetup about SDN and network programmability. So today, we are going to talk about a love story between developers and network engineers, trying to work together to make something useful for both. Because in the last ages, when probably you know this sentence that it works in my laptop, so it should be working in the network, this is not going to happen anymore. We have to work together and build services together that can be useful for all of us. So let's start first with the problem statement, just to understand the rest of the presentation. We are running in an hybrid ecosystem. Schibsted, as I mentioned before, is running a lot of different companies, and acquiring these companies means acquiring different IT stack. And at the end, you get a lot of stuff on premises, a lot of stuff in different cloud environments, and get that you have, at the end, an hybrid ecosystem. Because this is the usual situation when you are coming from a legacy or an old approach IT to a more cloud-based approach. Probably this is a problem that you share. So another poll again. How many of you are running in an hybrid ecosystem right now? On-premise, more people. Probably more people are running on this environment, and probably is going to do this step if you choose to go to the cloud. So when you are in these environments, you get something like this, when you have several platforms, put here the name of your cloud provider or the on-premise, where you have several networks that belongs to different services, and these services can be spread across several platforms. And the idea is that you eventually have to connect them, and you can get something like this. What does it mean? It's that to connect these different networks, you can use specific solutions. Could be a VLAN in a data center, could be a VPC peering in AWS, or if you have to go to through different platforms, you can run a VPN, IPsec. So several technologies to achieve the same goal. But the most difficult part here is this. Most of the times, these platforms are run by different teams. You can get a global operational idea, but different teams, different skills, it makes it difficult that this works as you expect to do. So this was more or less my face when I saw the problem that we had. And we evaluated the situation, and the conclusions were 3. The first one is that, by default, the way to interconnect services is through internet. It's good, it's an option, but it's not always the best. I mean, you have 2 different services in 2 networks in the same platform, and by default, this should be going through internet, having an extra latency, less performance, higher costs. So by default, internet is a good option, but it's not always the best. Going through a manual provisioning, it doesn't scale. In terms of velocity, agility, you are not performing as quick as the users, the developers expect from you. And also, it's prone to errors. So lack of consistency. It doesn't scale. And finally, not all your traffic is encrypted yet. So probably most of your applications, user-facing, is running HTTPS. But when you are talking about backend, sometimes you are not in this step, in this place. So we tried to solve all in one. A small squad of network engineers, or not software engineers, so basically network engineers, came together and proposed some cool design, network design. This is not rocket science. It's something that if you just go do a Google search and look for transit VPC, you will get something like this. And the idea is quite easy. Just put in the middle, in the center of the picture, some virtual routers, routing functions, that will concentrate all the different connections from the different networks. So you have like a distributed central point. You only have one connection for connecting to everywhere. It simplifies the problem. To do that, we just leverage on using quite standard technologies like BP and IPsec, and running BGP. BGP is a dynamic protocol that is the one that supports internet. But in this case, we are running in an internal network, so basically just to propagate the network information and to make this happen in a dynamic way. So when you connect, you just propagate the networks that you know, and the others will get this information. So it's quite simple to understand. And around this, we created like a feedback loop when all these virtual routers were provisioned with an automation tooling. In this case, we used Ansible and Napalm. I don't know if you know about Napalm. It's a Python framework just to automate networking configuration and operations in a multi-vendor scenarios. And all this information was processed across in an analysis platform that was based in PM. It's quite difficult. It's PMACCT, just to get all this information from the NetFlow information and try to get some feedback loop, get some actions from this, and reintroduce in the loop and modify the network accordingly. So it was quite simple to understand, and we was quite confident that this is going to be solving all these problems. So we went to upper management, and we failed. And we failed because this solved most of the problems that we were aware of, but not the ones that was expected to solve. So we learned. We learned a lot of things on this process, not technical, but quite useful things. The first thing is that you should focus always on your user. So see what they understand, what they value from you. So what the service should solve, which is the problem. Also, focus on the urgent things. So you can solve a lot of things, but why not first start with the things that gives more value to the end user? And finally, just understand that your solution should fulfill a requirements that are some of them at one point, but it could change in the future. So your solution should be modular to accommodate these changes. And then we just went for the second round and tried to create a network service. So instead of doing a network, we just created a service on top of it with some things in mind. The first thing is that developers that are our users love being autonomous. They are used to do that in running dynamic infrastructure. So we have to accommodate the same requirements. The network should not be a blocker for them. So keep this in mind. Developers want to be autonomous, and you have to enable them to do like this. Developers also love APIs. So just provide an API for them. But note that this is a plural. They love APIs, but they don't love having to handle 10 APIs to do the same thing. If we don't do an abstraction of the network, if you are running over several platforms, several vendors, you have to know, as a developer, all the different APIs. And this doesn't make any sense. So just create an API that solves all this problem. Developers don't care about network details. This is like a commodity that should be there, and it should be working. But on the other side, they love performance. So the network should be the one that takes the decision, the logic, just to understand what's the best solution, service that the network can provide for them. Also, we should be able to accommodate changes on the requirement that they have. So be able to support several providers when the requirement came. Why not, if we are running a service, just check continuously that the service that they expect to have is the one that they get. So we are running this in a periodic way, just checking that what is expected to be is the one that is in place, because it's a running infrastructure, and also just notice them about something has changed or not. And finally, because we are running a network, we have information about what's happening behind. We have packets, we have flows, information. Why not proceed all this information and give them extra value just for them to realize which are the network dependencies from a developer point of view. When you have a code, a developer project, a package, you know your dependencies but about other packages. But sometimes you don't really understand which are the dependencies that you have at the network layer. So all this information can be useful for them. So the new approach was quite simple and was create an abstraction layer, network abstraction layer, and put an API in front of this. With this information, we can just operate several platforms, and we create an API that can be used by different actors. These three actors, basically, the network engineer is the one that creates the service in this case, and specifies the logic, the quality that the network should provide. So we understand which are the use cases that we support, and depending on the situation, we just react depending on that. On the other side, on the right side for you, the security engineer is the one that can specify compliance. So for instance, which are the ports that should be open for all the applications, because it's a compliance rule. And finally, and it's the star in this diagram, is the application owner. So we work as a DevOps and focused service teams that we can run all the application on our own. So we are the ones, the application owners are the ones that specifies which is the application connectivity that should have. And through this REST API, just make it possible to happen. So underneath this abstraction layer, what we have is what we had before in the other picture. We have this diagram that have several platforms with several networks. And also, in the middle, we have this routing process that can just connect several providers. Could be on-prem, could be on cloud. But notice here that we also took into account that for specific platforms, we can leverage on internal services. So in this case, if network B1 is going to connect to network B2, it doesn't make sense to go to this routing point. Just connect them through the better connectivity possible solution that we can get. The architecture of this service, because it's a running service, is something like this, quite simple. You can map this like the API, the worker, that is the abstraction layer. We have a message queue just to decouple the different services that can work at different times. We have the entry point for the users that is going to a load balancer and DNS. Everything is running in dynamic infrastructure, so we can just collect all the events, all the metrics in a central point. And it's important to notice, because you will see later why this is autonomous. We are running through a single sign-on solution, so you can just onboard on this service on your own. As a network engineer, I don't know who is the user of this service. Just go through the process, and you will get the access that you need. Finally, and these are the dotted lines that you can see here, these are the platforms that we have in the roadmap to support. Right now, we are supporting AWS, and we are starting to think about how to move connectivity to on-premise. This service is written in Python. I'm following 12-factor application. Probably you know about it, but it's a well recommendation just to create code and to make it really easy to deploy in dynamic infrastructure. Probably nothing new for you. Some code snippets for you to understand what we have built. Here, there is a Python code. Don't just focus on the details, but you will see that the worker, that is the one that creates the connection, the first thing that have to do is you get a request to create a connectivity between two different networks. For the developer, that is the owner of the service, they don't care about which will be the result of this connection. They don't know if it will be an internal link, a VPN, whatever. So the first part that you have to do when a connection is triggered is go through an evaluator process that, depending on the type of the connection, returns and creates a specific connectivity. In this case, if the connection is both the resources are in AWS, we just spin up a VPC peering. So this is the logic of this evaluation part. And this is just for you to understand how we interact with the different APIs. It's in the AWS VPC peering connectivity. We have a create method that just talks with the specific AWS API just to create the peering and just deal with the different exceptions that we can get. This continuous integration and deployment pipeline probably is nothing new for you. This is mostly thanks to our delivery team. And it's nothing special. Probably all of you know how it works. We have a version control system there. We are running two different unit testing, integration testing. Always important, we are humans, so we do code review just to approve all the changes. And finally, just a deployment pipeline with acceptance tests. We deploy all the services. So this is how we built our service. But here, it's important to notice that this service could be used for another purpose, because this pipeline is quite similar to other services that we have in Schibsted. And something that probably you have in your on your business. And the question here is that in your continuous integration deployment process, do you deal with networking? You spin up VLANs, you spin up this kind of stuff? Probably not, because network is not able to react so quickly to your changes. But in this case, if you have a network service that creates this kind of stuff dynamically, like a cloud provider, you can leverage on that. You can integrate on your continuous integration and deployment process a tool like this, just to automate all this process and make that the changes that the network is going to happen on production, you can test this in development stages. Finally, just next step on this project, if you have been using Kubernetes, you are quite used to read this kind of YAML files that probably you can read because the color is not the best. But the idea is that you define what your application should look like from a platform as a service perspective. And you should focus on this specific last part. So when you deploy an application, why not you can define the specific network requirement that you have? So this tooling that reads the YAML creates all the stuff in the cluster. And finally, because you are defining in the connectivity section which are the other services that you should be connected to, it happens. So magic happens without caring about the details on all this stuff. This is the service. This is how we build it, and we are running. And now, just to show you a bit about how the user feel with this, we are just going to go through a small demo about how it works. Don't expect a real-life demo. I just recorded, so we are going through this. But just to get you some context about how it works, these are the mappings that we are doing. So these are the naming conventions that we have in the service. So basically, a network is a resource. A connection is a connection. There's nothing else here. A service is just a bunch of different networks that can be together. And finally, you have a provider. A provider is the different platforms when you are running the networks. The scenario that we are going to show is this. Is just a network to network. Translated to AWS terminology is a VPC to VPC in a platform AWS. So let's go for this video. And it should start. No. So we have always, this is a backup plan. So the demo starts just running in dynamic infrastructure. We have a clear account in AWS. In this case, you can see that we are in Paris. The first thing that we do just to test this is deploy the infrastructure that we presented before. It's two different VPCs in the two different accounts. We have to wait for a while until the CloudFormation stack runs all the dynamic infrastructure. You can see here that we are running, spinning up an instance. That is going to be the one that we are going to test. Finally, when the stack is created, so the infrastructure is ready to test, the next step is just to check that what we have created is nothing else than an instance, a VPC, a subnet, all the stuff that we need to demonstrate that this works as expected. Next step is just to check that this instance has a public IP. That is the one that we are going to get to get into the instance just with an SSH. And just before getting into the instance, we can check that this instance in the root table only have the local network and the default one to internet. This is just an SSH to the public instance, where we are going to run what a network engineer does to test, do a ping. So we are going to do a ping. Here you can see the private IP of the other instance that is running in another account. In this case, in the same region, but we also support multi-region. And here you can see that we just leave a ping that is not working from the private IP of one end to the other end. You can see here that in this account, we don't have a peering connection with the other. So this is the explanation that it doesn't work. And this is the user experience that we have at Schibsted when we have a service catalog. And it's easy for the user just to go to the get access, because reaching this portal, you have to be single sign-on and submit get access. So it is completely decoupled from the user experience. It just on their own, just go into that, ask for this, and in the application panel, they get access to the GSN, that is the naming for us in Schibsted. Interaction with the service right now, this is a quite young service. It's not run through a frontend. We just have a CLI that we install as a package with Python. That is nothing else than a wrapper of the API. So this service was designed as an API first. But just for easily integration, we just created this kind of CLI. Here you can see that the first thing that we are doing is create a service. And a service is nothing else than a name and a user that has been created before. And we create, the next step is create a provider. That in this case is AWS with the ID of the service to the one that belongs to, and the details, the specific details that we want to provide as a provider. This is done by a user, not by the network engineer. It's done by the owner of the user. Next step, and this happens automatically, is that when you create a provider, the system has rights just to scan all your different providers and understand which are your VPCs. And here you can see that these resources get all the details automatically. So we get the subnet that it has, and also there is an extra field just to understand or to define layer 4 filtering. And the cool thing is that with this information, you have a resource on one hand, another resource on the other side, and you just go for a connection create. So with both resources are UAD4, you just go for that and connect them. This is going to happen now because the one just here, you can see that the connection is established. What happens behind is completely out of the user, and it's not synchronous. So you just ask for a connection, and the worker, in this case, there were few connections in the dep environment, happens quite quickly. And you can see that the ping is here. So what is the service doing? The service is doing several stuff for the user. It creates the VPC peering because you need a connection, but it also takes care, in this case you see the VPC peering that is created, and the user doesn't know anything about it. But it also takes care of the route table. It means that it takes care of the link, the routing information, and finally the security groups. You can see here that as you can create, you can also delete a connection. And in this case, you can see also here that the process is not synchronized because you asked for a connection to be deleted, but it takes some time. And in the next iteration, you can see that the state now changed to delete, just to show you that this is not a synchronous operation that takes some time. Here, this has been accomplished without any human interaction. And this is happening because the owner of the service is the same for both services. It's just a test user. If you are, this can happen in a big company, a Schibsted. Here, losing some light. Finally, you can see that we are deprovisioning the, yeah, it's the end of the video. We can see that we are deprovisioning the same connection. This happens in a big company that there are different service owners, and obviously you can just be able to handle which are the connections that you want. So if you're just asking for a connection to another service that has not explicitly said that is going to be accepted, this goes through an approval process with a notification and a token, approval token, just to make this happen. So it doesn't happen by default. You have to explicitly define which are the authorization paths. And now, just continue with the presentation. And the last part, the takeaways. So there are several takeaways, and I distributed in two different sections. For software engineers, first thing, and it's important, it's that you shouldn't underestimate the effect of the networking decisions you take. Because the effect of networking problems or issues or benefits have a lot of impact on your application. Packet loss, latency, these are things that should be taken into account and controlled. Also, you should have the same requirements that you have for your continuous integration and deployment tooling, the DevOps tooling. The same should be asked and requested for the network. It's up to them to be able to handle this, but it's possible. Also, to maximize the effect of DevOps, this requires everyone in the organization running on the same direction. So involve them on this process. And the last one, it's important, adopt a network engineer. As I learned since the last 3 years, a lot of people has helped me just to make possible that today I can share with you these ideas, these learnings. So they are there willing to learn about things that probably are not on the day-by-day job, but they are quite interested on learning and growing. Finally, for network engineers, don't be afraid of going out of your comfort zone, because it takes some time, it takes some effort, but it's worthy, I can say. And I think that you should be able to learn some coding. Some coding is necessary and gives you superpowers. It's necessary because you don't need to create this kind of service on your own. You can just leverage on other services, tools that are built, and you just go off the shelf with this tooling and start doing things. But at some point, you should need some kind of cluing between this, and some coding will be necessary for you. Also, adopting a DevOps and being here in this conference is a good starting point, will speed up your business and also your career. Take this into account. Don't be afraid, because there is a community waiting for you. Take note if you want to join this community, Network to Code. There is a Slack channel on the internet. When I joined this community 2 years ago, I think that we were around less than 100 people. And today, there are thousands of network engineers around the world sharing learnings and cool things on this Slack channel. And finally, and remember that networking is a key skill in IT. So just focus on bringing it close to the business, that it will be valuable as the applications are. And my last words, and it's important for you to remember, is that if he can change, so can you. And just do this step forward, and you will have probably a really good experience. So if you want to take any photo, and thanks for your attention. You will have here some related material. Our slides are in HTML, and also some learning links that I have took through all this process. So have a look if you want. And if you have any question, I'm here for you. Microphone is coming, probably, or here in front. OK. Sorry.
Hello. Thanks a lot for the talk. Is there anything of the tools that you've been presenting, or part of them, or libraries, open source? Or is there any plan to make them open source?
OK, so this project, this service, is in production, but it's not open source. It is really actually something that I was considering, because I think that it could be interesting for people to see how it works. And at the end, there is no internal details about how it works. It's just an abstraction layer. So it could be something that we consider in the future to make it open source. But there are also some tooling or commercial tooling that does quite similar things in the market. So in our case, we just decided to go for a build-it approach. But we could think about that.
And just thinking about the AWS example, what would be the difference of building yourself something like that, describing infrastructure using something like Terraform, that it is not a service for someone that wants to build it, for example?
Can you repeat, please?
Yeah, you've been describing sort of abstraction of how to describe a complex infrastructure that does VPC peering across a couple of VPNs. And what's the difference of what you're building from using, for example, Terraform to describe that?
Okay, so in this example, I just demonstrate an AWS example. So this is something that you, just with a custom solution, you can just do with Terraform or something like this. But there are some other pieces of this project. So one of them is that we are going to support multiple platforms in the idea that there is some logic to spin up or just create different kind of connections that are not only AWS related and can be run through a VPN, and these are more complex to create. And the other thing is that we are taking the approach that we don't know, we don't own all the different parts of the picture. So we cannot decide for all of the users of this. So the user responsibility just to choose which are the connections should be delegated, and we are delegating to them. So they can have to choose. In a Terraform, you cannot do all this kind of logic on that. So we are doing like it. Behind all this abstraction, now is basically leveraging on Python, APIs integration, but we could accommodate other tooling like Terraform for specific use cases.
Thank you very much.
Hi, I got a question. How do you keep the state of the network resources and what are actually deployed, why not, how is going to delete something? Or?
Okay, so one thing that I have not mentioned in the talk, my fault, is that a part of, there is just two pieces of this. There is the API, that is the one that has the connection to the database and has the desired state of everything. And there is the worker, that is the one that just talk with the different infrastructure and just check which is the actual situation. So as a user, as an owner of a service, I just want to connect one resource to another. And if I have the approval of the other side, that in the case that you are the same owner, you just get the approval by default. The connection, the state is that you want to make it established. Is your aim, your objective. But on the other side, it will take some time. So the worker is the one that connects to the infrastructure, creates the VPC peering on both sides and accept on the other, create the route table, create the tags, create all the stuff related to this connection. And a part of creating this connection, it just tracks it. Every some minutes, it connects again. If the connection should be established, is the case, we just connect every 5 minutes to all the infrastructure and just check that it's as it should to be. So we just connect to the real infrastructure, get the data, the state. So the state is in the actual infrastructure. We just handle that. For the acceptance test that you have seen in the continuous integration, we deal with real infrastructure. So we connect to the infrastructure, we just spin up all the different stuff that we have to do. We do the same kind of demo that I have done, but automatically. And just finally, we get all this information. So the state, it's in the real infrastructure. We just check it periodically just to check that it should be.
I'm also talking about I believe you could name the decided state. So how do you keep the declarative?
This is completely up to the user. So the user just, the connection has a different flow of states, finite machine state, and the network engineer has not any part on this process. So it's just the user that just deal with the connection as it was itself and handle all the different process, and it defines what they want. It's a declarative status. And finally, you get the actual state. That is the one that the infrastructure has. And it's the one that is mapped. So you can have the desired state as an established one, and the actual state could be an error, because you want to establish something that is not possible to establish. So the actual state is an error. and you track everything in that database. And you can just recover this connection, do whatever you want. Another question? No? Thank you very much.